We are learning pavement material and characterization. Previously we have seen a CBR test, which is a kind of penetration test. We are learning about subgrade soils, what kind of test we can perform on the subgrade soil, uh, wherein penetration test was one of the tests which is performed on the subgrade soil. Today we will learn how to obtain the CBR value from the data collected through the tested specimen by a penetration test. When the data is represented or data is plotted graphically, it shows a penetration curve. Previously we have seen that to obtain the CBR value we have to apply a formula which is load carries by specimen divided by load carries by the standard specimen into 100, which will give a value in the percentage, and that value is known as the CBR value for that particular subgrade soil. So our today's task is to obtain the CBR value from that penetration curve. So next we are moving on the penetration curve. Here you can see the load penetration curve is plotted. Alternatively, the load value here, as you are seeing, this is the load dial readings. This load value may be converted to the pressure values, and the pressure versus penetration curve may be plotted. Here we have penetration values on the y-axis, on the x-axis, and on the y-axis we have load dial readings as a divisions. Here the penetration value is in mm. If we recall the penetration test procedure, we have talked that the load is applied through the penetration plunger have at uniform rate of 1.25 mm per minute, and to be very specific, the load readings are recorded at the penetration reading of 0.5, 1, 2, in between that 1.5, also at 2.5, at 3, 4, 5, 7.5, 10 and 12.5 mm. These are the very specific reading which are be collected from the penetration test. So let's explore this penetration versus load or load penetration curve. So the typical curve may be obtained as shown in the figure. The normal curve is with convexity upward as a specimen 1. Here you can see this is a curve. This is a normal curve for a subgrade soil, like convexity at upward sides. Okay. Now the load corresponding to the 2.5 mm and 5 mm penetration values are noted. Here you can see this is the curve, and for this curve we have a value at 2.5 mm and 5 mm are represented. So now if we talk about this for the specimen 2, sometimes a curve with initial upward concavity is obtained, indicating the necessary for specimen number 2. In this case, the origin is established by drawing a tangent from the steepest point on the curve to intersect the x-axis at point P. Here you can see that this is the concavity, okay, and here at the point where a path is changed, though you can say this is the kind of tangent point. At this tangent point we have plotted or we have stretched a line on the penetration line. Yes, so this line is intersect at the penetration line. This line is known as the corrected origin for that particular specimen. So now when you have plotted this tangent line, then this curve is almost similar to the curve of specimen number 1, which is generally known as the normal curve for the load penetration value or the penetration curve. So now the load values corresponding to 2.5 mm and the 5 mm penetration are noted from the graph as here mentioned in the dotted line. Here you can see that the origin is started from this point. So now we are taking the reading of 2.5 mm. So from this origin we have to move 2.5 mm towards the positive x direction, and at that moment 2.5 will be at here somewhere at 4.4 or we can say 4.5. So for the specimen number 2, the 2.5 mm penetration value we will get at this point, okay, and the same way 5 mm penetration value we will get over here. So now the CBR value is calculated from the formula as we already known, we have learned previously that the total load for that particular specimen to the standard load for the same penetration into 100, and you will get the value of CBR. Generally the CBR value at 2.5 mm penetration is higher, and this value is adopted as the CBR value of the soil sample. However, if the higher CBR value is obtained at the 5 mm penetration, the CBR test is to be repeated to verify the result. If the CBR value at 5 mm penetration is higher, in the repeat test also this higher value is adopted as the CBR value of the soil sample. Now the average value of the minimum 3 specimen is to be reported as the CBR value of the soil. So this is a kind of standard value, we can say that the 3 specimen value that has to be reported for the correct soil CBR value. Here example is given that if we take this example on this according to these readings shown in the figure, that load at 2.5 mm penetration, if we say for the specimen number 1, okay, if we talk about the specimen number 1, then we the load at 2.5 mm penetration, so this is the 2.5 mm point, okay, and for that this line is inside over here. So let's say the load for 2.5 mm penetration is 32 kg, and same way load at the 5 mm penetration, so 5 mm penetration approximately here, yes, at the middle of 4 and 6. So this 5 mm penetration showing the value of load is around, we can say here 49 kg. Okay, so now the standard load, we know, we have already mentioned that standard load for 2.5 mm penetration we have 1370 kg, and standard load at 5 mm penetration 2055 kg. Yes, so, okay, so according to that we are applying these values to the formula of CBR. So so CBR for 2.5 mm penetration 32 upon 1370 into 100, and same for CBR 5. So we get the CBR value for at the 2.5 mm penetration is 2.33, and CBR value at the 5 mm penetration is 2.38. So as we discussed, here we have the penetration value at 5 mm penetration is higher. So at this particular time the CBR test is to be repeated to verify the result. After verification, if after verification you are getting same value for the CBR, at that moment you have to consider the 5 mm penetration value as the final CBR value. So this is how we can get the final CBR values from the load penetration curve. Now according to IRC 37 2001, if the maximum variation in CBR values between the three specimens exceed the permissible limits, the CBR test should be repeated on the additional 3 specimens, and the average value of the 6 specimens, the previous one 3, the original 3, and after repetition additional 3 specimens, so total 6 specimens is to be taken as the CBR value. So here the permissible variation between individual CBR tests are given in the table. And if the value of CBR is is less than 5, at that moment the maximum permissible variation is plus or minus 1% in the CBR value. If your CBR value is in between 5 to 10%, at that moment plus or minus 2% of CBR is permissible for the final value. Same way at in between 11 to 30%, the 3 plus or minus percentage value is allowed, and above 30% of CBR value, which is rare, at that moment the maximum permissible variation is plus or minus 5%. So this is what all about a particular CBR value. The next concept is effective CBR. What is effective CBR? So where there is significant difference between the CBR values which is of the selected subgrade soil and the embankment soil, the design should be based on the effective CBR. We can say that the soil which is selected for the subgrade soil and the soil which is already available at the embankment, that both soils have the significant difference in their CBR values. At that moment, this effective CBR concept is applicable to consider the final CBR value. So the effective CBR of the subgrade can be determined as per the graph. Graph is about effective CBR of the subgrade value and the CBR of compacted bottom material for 500 mm thick layer or 5 mm 100 thick embankment soil. So now if we can say the one value is around 16 and one value is around 20, so at the 16 value and the 20 value, the value which is shown will give the effective CBR value, and that we have to consider for the final CBR value. This concept is very crucial and very important when you are designing a pavement or pavement layers like subgrade, subbase, base. So for that, the subgrade, as we already discussed, that the subgrade is the most important layer we are forming for the pavement. So to design that particular layer, the effective CBR value is most important parameter. So now next important concept which we need to learn, or which we have to learn for the soil, that is resilient modulus. So now first of all, let say what is resilient modulus. The resilient modulus has recently been accepted as the most representative test for the soil. Even it is used for, this concept is used for aggregates under the highway loading conditions. Stresses in pavements is due to repeated moving wheel load, and hence this test simulates the soil under a series of load application. The resilient modulus, which is generally denoted as MR, is elastic modulus which is obtained from repetitive load test that simulates the actual pavement loading. It is calculated as the ratio of the imposed repeated deviator stress, that is sigma d, to the recoverable axial strain, which is epsilon r. Sometimes we address this as a ER, which is recoverable axial strain or elastic strain. Here the figure shows the straining of a specimen under a repetitive load test. At an initial stage of the load applications, there is a considerable permanent deformation as indicated by the plastic strain over here. Now, as the number of repetition increases, like this is first, second, third, fourth, fifth, sixth, seventh, so as number of repetitions increases, the plastic strain due to each load repetition decreases. Here the first plastic strain is at this, the second we can say for the first this is the plastic strain, for the second this is the plastic strain, for third, for fifth, for sixth. So as you can you see here, as number of repetition increases, now you can see here the major difference between that plastic strain. After that this is not exact tangent, but if we draw a exact tangent line here, we can see the gradual decrement in the plastic strain. So after 100 to 200 repetition, not 10 to 20, it's about 100 to 20 repetitions, the strain is practically all recoverable, as indication by the epsilon r, which is like ER in the figure. You can see over here. So a triaxial device equipped for repetitive load condition is used to carry out the resilient modulus test. The test may be conducted on all type of unbounded pavement materials, ranging from cohesive to stabilized material. However, this test is not available in most cases, and hence some recommendations are made to correlate the CBR values with the resilient modulus. Here the IRC 37/2012, which is the upgraded version, have given the relation between resilient modulus and the effective CBR, and that is 100 into CBR till the CBR value of that subgrade soil is 5, and if the value of CBR is above 5, at that time the modulus of resilient is noted as a 17.6 into CBR raised to 0.65 value. So this formula will give the final resilient modulus for that particular type of soil. Okay, so for this lecture, this is for about subgrade soil. This is the whole discussion about subgrade soil. From the next, we will continue with the road aggregates. Thank you.